So welcome everybody. Today we're going to be talking about computational access and use of texts and data that are behind paywalls, challenges and resources for that. So I am Katie Zimmerman. I'm the Director of Copyright Strategy for the MIT Libraries, and I'll be joined by my colleague Ye.
Hello, everyone. Good morning. My name is Ye Li. As Katie mentioned, I'm also working for the library, and my title is Librarian for Chemistry, Chemical Engineering, and Material Science and Engineering. Welcome to attend our session, and we'll also have our colleague Laura Hanscom here.
Hi, my name is Laura Hanscom. I'm the head of the Scholarly Communications and Collection Strategy Department, also in the libraries, and I am here to help troubleshoot, possibly answer some contractual questions that might come up, and general moral support. So my video will be off, but I am around if help is needed. So it's lovely that you all are here.
Thanks, everyone. Yeah, as you may be able to see that our session today is going to be on the webinar platform, so please feel free to type your questions into the Q&A section. If you need help with anything, please feel free to use the Q&A or using the chat window to let us know, and one of us will help you. Okay, without further ado, we'll have three major parts of today's session. First part, we're going to do a brief introduction of computational access and use overall. And then Katie will walk us through some major copyright and contractual issues related to legal legal instances in the second section. And in the last part, we're going to review some contract license together to have some real world sense of how that goes. And just to warm up a little bit, could everyone please go to this browser window? I'm putting the link in the chat window here. If you wish, please help to tell us which category does your field of study or interest belong to, so we can know some of the resources to talk a little bit more about. Thank you, everyone. And I see some of you just joined us, and besides that poll link, here's a link to the slides too. Okay, cool. Looks like we have a few more science and engineering folks, but this is a very good mix of class here. And my second question for you, if you stay on that same page, is why are you interested in computational access and use of texts and data behind paywalls? Just some quick reasons why you're attending our session today, so we have some idea on what we want to focus more on. So one of you are interested in text and data mining for newspaper articles. Literature searches are too hard. Yeah, so digital text analysis of newspaper reviews and how to navigate legal issues. Great, you'll come to the right place. Harder to get Elsevier articles now than before. Yeah, thank you. We have our team here that may be able to help explaining some of the things going on with between us and Elsevier a little bit more. So feel free to ask your questions in a moment. Thanks everyone for typing. And for one of you mentioned about literature searches are too hard. Just want to clarify that our session today is not going to be about regular literature search in databases. Our session is really more about computational access, which means that we use a program or a piece of code and try to retrieve data or metadata in a bulk. Like essentially, we're retrieving a batch of records meeting certain criteria through different ways, but this is not the traditional type of literature search. So if that's what you are interested, please feel free to contact me later. I'll connect you to the right specialist to learn more about that. Okay, great. Well, let's, yeah, sorry, didn't mean to enlarge that. Okay. Yeah, just a little further explaining about what we meant by computational access and use. Traditionally, when we are reading a research article and looking into a piece of data in either a table or a figure, we use our brain to digest the content and process information so that we understand it. Now, with computational use, what we meant is the computer would get the data and the texts on its own, and then I shouldn't say on its own, under our direction. And then the algorithm would work on the data and the text to review some patterns and insights through generating some analytics or statistics or applying certain carefully designed algorithm so that we have those patterns to help us to get insights without directly digesting tons of data and text at once. This type of research really has been rising very fast since 2010. Then really because of the exponentially growth of computing power that's available for more people. As you can see in this figure, since 2010, many of these popular keywords like text data mining, data science, machine learning, artificial intelligence, digital humanities, they all increased with publications over the past decades. And excuse me. When we're talking about the computational use, we oftentimes means that the text and the raw data are being mined. Like we oftentimes use the text and data mining to describe that process. And then once they are mined, they become structured data. So the machine would be able to understand the structure and know what the machine is looking at through the description that the metadata provides. And those structured data then, sorry, we can apply further algorithms like statistical analysis or machine learning algorithm to review those insights and knowledge. And eventually we get to the domain of artificial intelligence that we use those kind of insights to inform actions and automate process. Here is a quick example of its application in chemistry. Looks like we have at least a couple of us in science and engineering here. So just a quick walkthrough of this process. And for those of you who are in humanities and social sciences, hope I can explain this example with some details that you would enjoy too. So this is a publication from one of the MIT research groups in science. And it's about building a robotic platform, but this robotic platform will be informed by machine learning algorithms behind it so that it can do the automatic synthesis process of molecules itself, and also assess the reaction process and further optimize the next reaction to try. So in order to have that happen, First, the chemical reactions information or data were reported in some of these primary literature. That's how we describe research articles in science and engineering. So they can be drawn in this kind of reaction schemes, and then also can be described in sets of texts. So earlier in the days, there are indexing efforts. That's even before computer becomes popular. There were already indexing efforts for manually to index those chemical reactions from literature and organize them into structured data. And when computers come into picture, they get further structured and become machine actionable or machine readable, and become databases where human can use to search and retrieve literature. Now that structured data can be stored in different kind of machine actionable format, for example, XML and RDF. The screenshots here is really showing how a reaction looks like this could be stored inside the computer as numbers and structured tagged text files, so that the machine can know exactly which chemical compound and which reaction that this particular article would be describing, and relate that to that article. And this structured data can be aggregated in very large set, and now through some sort of algorithm, there can be transform rules, like essentially if A plus B can be converted to C under certain condition, and those rules will be summarized from that tons of reaction data. And further, those rules can be used to train the models that can be used to predict how a certain molecule being synthesized. And that model can be then be used to predict the synthetic route, and eventually that route can be used to inform this kind of automatic robot platform to synthesize new compounds, and then also collect those real-time data observed from the process and feed back into the process from the beginning, and to further optimize the next step. So that may be a very particular science-related example, but here we want to summarize a little bit more on what we can be looking at when we talk about data and texts for computational use. It can be bibliography metadata, so essentially the articles, or we also mentioned a patent or news articles. Some of you mentioned that there are authors, publication name, and their affiliations, and even their citations. All those information can be the metadata, and that's one type of tech data that we can use for data mining. And in fact, oftentimes you do need that first step so that you can decide which full text that you're gonna look into further. And then we have all these kind of broad categories for different types of data. It can be texts or narratives from publications. It can also be artworks and music. And it also can be directly as numeric data. There can be experimental data, as we just saw for the chemical reactions, and there can be already simulated data or survey data in social science that we'll often get. And there can be other type too, but all of them will need to be converted into some sort of machine readable format, as we said earlier. For text particularly, if you were not born digital, then we oftentimes need optical character recognition mechanism to allow it to be converted into a way that machine can understand. And also in the meantime, correct any errors there could be occurring during the digitization process. And then those information will be either indexed, aggregated, evaluated, and eventually structured to put into the metadata provenance that's needed to really for machine to use this data under this context study were created under. And then that structure also gives opportunity to tag it with a sort of linked standardized vocabulary or ontology and a schema so that it really can be retrieved in the correct way. Like when you're searching using either an API service, or we'll talk about that more about that later, or in a standardized, or in another general way of searching for it and then retrieve and download the block of data. But if they are tagged already with a standard vocabulary, then it would be much easier to retrieve the accurate set of data that you need. And the format, if it's curated, then it would be much more interoperable across different types of algorithms. And we don't have time today to get into more of those details of how the data format can matter and what kind of standards are available for each field. But that's definitely something very important for efficient use of text and data, and very specific for individual disciplines too. And I guess once you are doing more of the computational use, you will find more of information on those. Okay, now, yeah, so all these different data sets at different stage can exist in many different types of resources. They can be books, journals, multimedia, like the traditional reference works, handbooks, encyclopedia, where the data has been indexed already. And there can be data sets that's created as a reference data sets. For example, NIST, the National Institute of Science and Technology, has a lot of standard reference data that were created for the purpose of people to check, but now they can be converted in a way that computer can take advantage of. Yeah. So, and then we have those metadata databases. We'll actually use one of them today to explore. We have those databases of curated or extracted data, as in the case example I was talking about earlier. There are more growingly open data repositories where people would put publications or data sets into an open repository to share with people. And that's a newer trend, and more things are available in that way. And we are hoping that in the future, we have more open and fair. What we mean by fair is findable, accessible, interoperable, and reusable data in those repositories. But before that, before that becomes dominant, we still have to deal with lots of these resources that's behind a paywall, but can provide us with rich text and the data sources. And the providers of these sources can range from such a wide range. They can be government agencies, as I said, NIST, and they can be the repository hosts, and they also can be publishers. Some of them are commercial publishers and or not-for-profit publishers, and sometimes they are professional society publishers. And there can be aggregators, means that there are some service providers pull sources from different publishers into one big large pool and be able to provide access to them. There are also database vendors, and then because of the new promise that the computational powers have made, many other companies are also having a rich sets of data, and which they themselves may be interested in developing product out of. And those companies can be informatics companies or data analytics companies, consulting companies, And even some manufacturer companies are having interest in that. They also have some in-house data that could potentially be used for academic research too. But the spectrum of the private providers here really meant that we have a range of different challenges, because they really have increasing concerns on protection of their intellectual property and their business interests. And through this spectrum, it's also likely that the more commercial interest people have, they are more likely to be behind paywalls. So essentially, the challenges we have are, first of all, sometimes we need to find additional funding beyond what we often have we often need to pay for our subscriptions of journal and databases. There can be technical issues, technological issues that we need to solve before we can access those data or texts through computer in big chunk oftentimes. And there are licensing issues that involve intellectual property and contract laws, and that's what we're going to cover the most in the second portion. And last but not least, oftentimes we need to negotiate with these vendors and providers so that we can get a good agreement to use this for research that benefits the future of science and the general public. So just a few quick real-world examples on those data sources we're looking at to explain a little bit more about some of the technological challenges we may have. So Crossref is one of the metadata data provider. Why so is because most of the publications we see nowadays has a DOI. If you have noticed, that's a digital object identifier. And Crossref is one of the organizations, or almost one of the most popular organizations to help register a DOI for a new publication. So they do host a large chunk of metadata, and they provide some services to allow people to retrieve metadata in bulk for their use. And some of the services are for a fee, but mostly for research purpose. You will be able to use their API for free. However, although the metadata is available, but the retrieval mechanism is comparatively limited. With the API, you cannot do much of the Boolean operation, so that may be a limitation there with the metadata for the retrieval. And I've been talking, so just reminder that if I spoke too fast of something, or if you have a quick question on something, please feel free to type them in either the Q&A or the chat window. Thanks. And this is a second example of JSTOR. It's an aggregator. It means that it pulls publications from different publishers and compile them into a huge database. And they do provide specific services for using those full text to do research, to do text and data mining research. And they, in fact, created this platform called Constellate. And you can use this platform to explore and analyze and request the data sets of full text journals that's published by JSTOR and also collected from other publishers they work with. Yeah, there are some tiered pricing model for participating institutions when you need a large data sets. So we are working with JSTOR to see how broad we can participate in their program here. If you're interested in JSTOR data, please feel free to reach out to us later, and we'll let you know our progress. And this is another type of example. Royal Society of Chemistry is a professional society publisher, and they do allow subscribers, subscribe institutions to do text and data mining with their publications. And there is a way that we can connect you with the publisher if you would like to retrieve a specific data sets for your use. And the last but not least example is a newer platform from Elsevier. Elsevier is one of the larger publishers, and we have lots of stories to tell about Elsevier. But today I just want to quickly mention that they do have this platform called Intellect, that where they essentially it's a little bit like a black box where they host their data there, and you can put your algorithm that you want to test on the platform, and then the algorithm can run on those data sets and give you the output. It's not very preferred by academic researchers because it's not transparent enough. Although they claim that they adhere to the FAIR principles, but it's really hard to say it's truly accessible at all, because you won't be able to fine tune your algorithm based on the details of the data sets. So some of the corporate researchers find it more helpful because they could pull their own in-house data into such platform and be able to work through the data sets together with Elsevier. But so far, academic researchers hasn't found it very useful yet. Okay, yeah. And in terms of the technical requirements for the text data, just to quickly summarize what we observed from many of these sources, of course, you oftentimes need a large amount at once. In the traditional way of consuming text and data, you oftentimes just read a small amount at a time, but now you need tens of thousands articles or tens of thousands records, data records, to really allow computer to do the work. And the format, obviously, it has to be electronic means, and some of those exist born as print that need to be digitized and standardized before they can be used. So the structure of the data is also needs to be really embedded and linked inside. I talked a little bit about that earlier, but it's what we observed from different sources. It's a huge spectrum. Some of them did better job with digitization and standardization. Some of them were not very good. So that quality is also a good parameter to evaluate when you try to decide which source to go with your research. And the access itself can also range from that broad range. Sometimes there's no digital copies at all. Sometimes you need to do copy paste a lot, which is not realistic. And some of them allow you to do some point and click export. Oftentimes there's a limit of how much you can export at once. So oftentimes we need to negotiate special permissions to do a large amount export. And there can be batch download arranged if we have agreement with those providers, and or batch delivery, which means that it's not going to be a download from a certain website, but just rather it could be email or FTP or any, like sometimes people even mail hard drives to deliver data sets. Another main electronic means can be allow you to use web crawler to really grab data from their website, as long as they know which IP you're coming from, and they would give you a special permission at a given time frame to do this crawler, and not blocking you. But the most preferred way of retrieving or computationally accessed data and text is the API services. So it's mostly interactive and much more flexible and secure. But it really requires most structured and interoperable data, at least metadata for such service. So for the next 5 or 7 minutes, we're gonna do an activity together to practice simply how to use an API. So API really is meant to be enabling users to retrieve data without knowing the server structure. So essentially, we can send a query to the server using either an URL or a Python statement or the Ruby or R codes and so on. And that as long as your query is structured as required, then the server will be able to respond with a structured and tagged format of the data, either in JSON or XML format, or sometimes it may not be that structured, but that standardized structure, but there definitely would be some sort of structure to be returned as the data that you can retrieve from the API services. And yeah, again, the benefit is that you don't really have to know how their database is structured. You can only need to know how you need to structure a query so that the API server would understand what you're asking. So if you don't mind, could you please quickly go to this Paywalls link again? Thank you. One of you have voted. Yeah, so just to understand a little bit more on everyone's experiences on API. Cool. Okay, so looks like not yeah, we do have someone who are very fluent with API. Yeah, so thank you. You might find this exercise a little bit too basic, but bear with us. It will. I promise it should be fairly short and sweet. Okay. Okay. So here's what we're gonna do with the activity. Please go to this link I quickly put into chat right now. It's a Google spreadsheet, and I'm gonna go to that spreadsheet together with you right now. So if you are here, looks like we only have a few of us, so you don't really have to make a copy of the file. Rather, you could just choose one of the tabs below. Sorry, somehow my menu is in the way. Yeah, so on the bottom, you can choose one of the guest user tabs and follow the quick steps inside the spreadsheets and go through those steps. We'll give ourselves like about 5 minutes, and then we'll come back to go through this together briefly. Okay. If you have issues with accessing the sheets or understand what we're supposed to do, please type in chat or in the Q&A. We're gonna help you. Thanks. Okay, we have about 25 seconds left, and hope you have had a little chance to play around with the spreadsheets. At least one of you have done some work here. And if all are ready with this, let's come back. So yeah, well, our meet on 5 minutes is over, and hope you find it helpful to go through this little process here. So essentially, what we're trying to do with this spreadsheets approach is trying to form a URL statement where we can use it to query the Crossref API server. So, and what we want to retrieve is the metadata of articles funded by Department of Energy, where the license is applied as the CC BY 4.0, which means the article should be an open access one, and the embargo, if there's any, should be smaller, should be shorter than a year. And we wanted to display the first 5 results from that retrieval. And what happened is here we have these conditions. One of them is the Department of Energy. In order for the URL or the query statement to understand which department we meant, we need the DOI of this to representing the Department of Energy. And there is a funder DOI index from Crossref where we can check that what the DOI is. So we already found it for you. And thank you to paste that into the cell. And once you pasted that into the cell, that data was fed into this URL statement here. If you look at on the top, the cell that D15 is the cell with that data, and it will be added to the statement. And so as the license information and the days information in from cell 16, 17, 18 is the number of results we wanted to display. Once we did that, and this statement, when we run that in the Google Sheets, it's going to retrieve the result and then give it to the cell number 22 and 23. If you notice that this 2 cells has a statement here for import JSON, and that's an extension function in the apps script we installed. So if you have copied this file, you might have noticed that you need to copy this app script to allow the Google Sheets to understand this function. And then you were like, there are 4231 articles that meet this criteria, and it retrieved the metadata, like the DOI title and funder DOI. Yeah, this article is funded by so many funders that it lasted for a fairly long rows. But the rest of the 4 of them are more typical that have a few funders, and the rest of the metadata are also included. So that's just to show you how the data can actually come to you even through a simple statement. Due to time, I'm not going to continue to explain further with the rest of the steps, but you can look into how the data look like in the JSON format by using that URL, and also you can modify this table to retrieve different types of data. Hope that this part has given you a little bit taste of, I mean, most of you are aware of API and knows a little bit, but just one simple way to know like there are simple ways to interact with API. And now I will pass it along to Katie, and she will walk us through some of the copyright and computational use case studies that to explain more. Okay, Katie, here you go.
Thank you. Yeah. Why don't we actually switch the screen sharing, and
Okay.
I'll start mine. Okay, are you all seeing my slides? Right. Okay, so we're going to shift gears a little bit and start talking about some of the logistical barriers that you might encounter when doing your computational analysis. So we've talked a little bit about the mechanics of how, we've talked a little bit about the logistics of how. Another important aspect of the logistics is the legalities. So copyright is frequently at least seen as one of those barriers. Hopefully we're going to talk about how it may not be as big of a barrier as it may seem. And we're going to try and demystify that a little bit. So first, just to talk about copyright generally, this is the basic statement of when copyright applies from the copyright statute. And copyright applies to original works of authorship fixed in a tangible medium of expression. And that can be things like literary works, text, music, dramatic works, choreography, pictures, graphics, sculptures, motion pictures, sound recordings, architecture, lots of sorts of things that can be copyrightable. And then we also have a countervailing position of things that are not copyrightable. So we have specifically stated copyright protection doesn't protect ideas, procedures, processes, systems, methods of operation, concepts, principles, or discovery. So what does that mean in practice, and how is that helpful? So we're going to take a little bit of a look at what isn't copyrightable, because if the data set that you're working on isn't composed of copyrightable subject matter, that's going to simplify your legal question quite a bit, right? Because then you don't have to worry about the copyright in the underlying materials. So several ways that things can be uncopyrightable. Things can be facts. They can just be true things about the world. You do not get a proprietary interest over facts through copyright. You can get a copyright over creative expressions around those facts, the way those facts are presented, but not the facts themselves. Anyone can extract the information from a copyrightable work and reuse it. Similarly, ideas, you cannot get copyright protection over an idea. Anyone is free to extract a concept or an idea from something and reuse it. Insufficiently creative combinations of facts and ideas. So you can combine facts and ideas in ways that generate copyright protection. Once you start expressing things, interesting data visualizations, once there's some creativity involved in the thing that you're creating, then there may be copyright as well. And if you're the user who is trying to reuse that, then you have to consider that copyrightable material there. But it's not anything. It's not any combination of facts and ideas. And the archetypal example here is a phone book. So there's a Supreme Court case about competing phone book companies. One phone book company copies the information from another phone book company. The Supreme Court says that what they have copied, which is factual information, it's name, address, and phone number of actual people who live in the world. It is combined, it is arranged in a certain way, but the way it's arranged is not creative enough for copyright protection. It's arranged alphabetically so that you can find the information easily if you need to look someone up in the phone book. And that is insufficiently creative to get copyright protection. So if it's less original than a phone book, then there isn't copyright implicated there. Other things that are uncopyrightable, works of the federal government, and works that have aged into the public domain. So copyright lasts for a very long time. It lasts for the life of the author plus 70 years if it's something that's being created today. But at some point, works that are copyrighted are no longer copyrighted, and then they're free for anyone to use. Okay, so how does this apply to computational uses? So for that, I have an example for you, and this example is the Google Books Ngram viewer. So you're welcome to play with this yourself. It is at this link here. I'm not going to go off into a live demo. I'm just going to stick to my slides and talk about it a little bit, but I do encourage you to go play with it because it's an interesting tool and it's fun to play around with. But so what this is, you're probably familiar with Google Books. It's a very large corpus of scanned library books. So Google partnered with a bunch of libraries, scanned millions and millions of volumes of books. Some of those books were undoubtedly in the public domain, but some of them were also undoubtedly copyrighted, but they scanned them anyway. For the books that are copyrighted, they don't let you actually read the text. They let you search within it. They index all of the words in it so that you can search for them and find out where they are and a little bit of context around them. And they enable uses like this Ngram viewer. So what this does, how this works, you can put in some search terms, I've put in some pronouns just to have something to look at. And it will show you the frequency of those words in the corpus based on publication year. So you can see that she went up relative to he within the corpus in recent years. And so you can see the word usage over time. So this is a kind of interesting tool for sentiment analysis, for you can imagine using this data for various applications. You can also play with what the corpus is. You could focus on a particular date range. If you focused on a date range that was entirely in the 1800s, you would be much more likely to have entirely public domain materials in your starting corpus. But if we're talking about recent years, there's going to be more copyright in there. I have a couple of different subsets of the corpus. I've got it set to English fiction right now. You can set it to a particular language corpus, and they have a couple of variations between British and American English and things like that. But the thing I want us to think about is the copyrightability and the copyright aspects coming into this. So I've said that the corpus underlying this undoubtedly contains copyrightable works. Harry Potter is in here. Latest bestsellers are in here. No one, including Google, is saying that this is entirely public domain works. There is copyright here. And the books that this is based on are copyrighted works. But think for a minute about what data you actually need to run this query. You do not need, well, you do need the full text of Harry Potter in among this other corpus. You don't actually need it in order. You don't need it. You don't need to be able to read Harry Potter in order to generate this graph. You need to know every single word that's in the book, what year the book was published, and so this is what the data that's underlying this tool actually looks like, and it is exactly that. So they've added a little bit of metadata about the part of speech, but they have the word that appears, the publication date, and then some frequency data. I believe the two columns, one is books and one is overall. So if it appears more than once in a book, then it gives you that information. But you've really got an alphabetical list of every single word in the corpus indexed by publication date and frequency. And this table is not copyrightable. I will say that fairly confidently. Google also makes it publicly available, so they would seem to agree. But this starts to look quite a lot more like a telephone book than like a novel. So you can think about that with thinking about how you can get from something that is proprietary and copyrighted to begin with and kind of extract the information you need for your analysis, depending on what it is, into something that does not have copyright strings attached. So that is kind of an interesting example there. Okay, so that talks about, so we just talked about copyrightability, but it's possible that that won't work for your analysis. It's possible that your basic unit of analysis is still going to need larger sections of text for some reason, or maybe your basic data involves images. That's a little bit harder to say, to distill down to pure information. So perhaps you still have copyright involved there. And even if you are, even if you're dealing with this sort of data, there's still copyright involved in getting to this data. So if you're doing the whole process, you're taking the book, you're making a copy of the book, you're probably making several incidental copies of the book as you clean this data and create optical character recognition and do all of the things that you need to do in order to get from a stack of books to a list of words. There's still going to be copying of the full work involved there. So is that copyright infringement? And the answer is no. So in the US, text mining is a well-established fair use. Fair use is our general purpose copyright exception. It is designed to be flexible. It's designed to apply to new technologies. It's designed to apply to computational uses and things that that the creators of copyright in 1790 weren't envisioning. So it is designed to flexibly encompass new uses that you might put things to. And so we have a 4-factor test that we use to determine if things are fair use. I'm just going to talk about it very briefly, but the 4 factors are the purpose and character of the thing you're doing, and that's really a focus on are you transforming this? Are you doing something new versus are you just using it for the same purpose that it was created for? The nature of that work, that gets a little bit towards the copyrightability sort of question. If it's more like a phone book instead of like a novel, then it's also more likely to be a fair use. The amount taken, how much are you using? Is it an appropriate amount for the amount you're using? And the market effect of your use. Is your use really something that you should be paying for, but you're not? The law is less amenable to that. But if it's something that is entirely new, there isn't a market for it, that is more likely to be a fair use. And the cases that we have in the United States that give us this, this is another reason I use the Google Ngram viewer as my example, because I can also definitively say that it is a fair use, because we have 10 years worth of litigation to come to that conclusion. And so Google was in fact sued over this use, this massive copying of massive amounts of books. They won that lawsuit, and so we have definitively in the United States, on the books, we have a decision that this is a fair use. So it's transforming the books. It's not using them for the same purpose. Reading with your eyes and computational uses are different purposes. That's a transformative purpose. You do have to, you are copying the entire book, so it's copying the entire thing, but that's necessary in order to be able to do the computational things that, that you are trying to enable. And that is perfectly okay under US copyright law. So that's good news. And so what does that get us? So that gets us creating your corpus, doing your analysis, and certainly publishing the results of your analysis. So the conclusions that you're drawing from your data set. Now you've got your data and you're doing your analysis and you're doing your sentiment analysis on word use over time or whatever it is you're doing. You can certainly publish those results. And if you've gotten your data, if you've managed to extract your data into something that isn't copyrightable, that can also get you publishing the data set itself. Perhaps less so if the data set still includes computational things, or sorry, copyrightable things. And so a quick picture of the ownership situation in this picture that I've painted so far. We have a corpus of copyrightable works that you're starting out from. It is a combination of uncopyrightable facts and ideas and someone's creative expression putting those things together. So that is the books that we're starting from. They have been transformed through the power of fair use into a transformed data set. If you are the researcher working on this data set, you may also have an algorithm, something that you have created that is copyrightable to the researcher or the researcher's institution, that is trained on the data set. And from that, you get research results and the resulting publications and presentations that come out of that that would be copyrighted by the researcher. So that is what this looks like. But there is frequently, and if that were the end of this, and if that were the end of the story, that would be a very good end to the story. That would be extremely encouraging. Unfortunately, there's frequently another aspect of this that we need to consider, and that is contractual terms. So if you did in fact do what Google did and started from the physical media and digitized it and OCR'd it and did all of that yourself, then copyright would be the only thing in play. And if you determined it was a fair use, you would be set, you would be done, you would be ready to go. But as Yaya kind of indicated, starting all the way from the print material is usually not ideal. That's a lot of work, a lot of expense, a lot of time to clean that data, get it into a usable form, get it into a machine readable format, and do that. If you're starting with something that is already digital, then you're no longer in the position of working purely with copyright. You are also almost certainly contracting for access, and the contract can put terms in addition to the copyright terms that we've already talked about. So those contract terms, contracts can sometimes have a very unfortunate clause that says no text data mining allowed. That would be unfortunate. Sometimes they are, and we're going to talk a little bit about how they can perhaps more subtly be an impediment if it's not strictly prohibited or if it's even encouraged, but there can be other things that make it difficult that you might want to take into consideration. So a note on what happens if you have something that you think is a fair use, but it would violate the access contract that has been signed in order to access this content. The answer there, it may depend. I'll give the lawyer answer. It may depend on the specifics of the contract and how that all plays out. If you're actually in that position, I encourage you to talk to a lawyer who can actually represent you, which I cannot. But generally speaking, it may not be a copyright infringement, whatever you're doing. It could be a fair use. It's not a copyright infringement, but it could still be a breach of contract. And so you could still be sued for breach of contract, even if you're not sued for copyright infringement. And I would argue that being sued for breach of contract is slightly better than being sued for copyright infringement for various reasons, but it's still probably not a position you want to get yourself into. Okay, so let's take a look at some contractual clauses. And I should say that one of the roles that I play at the MIT libraries is to negotiate our contracts for e-resources. So if your source materials are, excuse me, if your source materials are materials that you're getting from the libraries, then and they are electronic materials, then they are probably subject to a contract that I may have negotiated or Laura may have negotiated. This is something we both do. But this also could be something that if it's not a library product, researchers do find themselves negotiating these things for themselves as well. So these are good things to know about in that context as well. So this is a type of clause that speaks directly to that fair use versus contract clash that I was just talking about. This is a very good clause to have in your contract. And this clause basically just says that, excuse me, that regardless of any of the other things in this contract, which we're going to talk about in just a minute, what those might look like, this contract is not intended to diminish your rights under fair use. So this is something that you might want to add to a contract if you're negotiating a contract. It's unlikely that if you're receiving a contract that is written by the person providing the data, they're gonna write the contract in their favor, right? So they're unlikely to include it, but you do sometimes encounter it in the wild. This second example down here is one that actually the contract came in with the fair use clause already in it, which was greatly appreciated. I'm just gonna mute myself for a second, let you read that while I take a sip of water. Hold on just a second. Okay, thank you. So now I'm just going to talk quickly through some things you may see in a contract that might limit your ability to do computational use. So this isn't a case where the contract outright says you cannot do computational use. This could even be a contract that has a fair use clause in it. But these are some of the things that you might see that might, even if it's permitted under copyright, even if it's otherwise permitted under the contract, terms like this would make it very difficult to computationally use the resource. So these are things that you might want to focus on to change if you were negotiating this contract. So this is a section on restrictions of use, except as expressly stated in this agreement or otherwise permitted in writing. You agree that you will not, point 1, abridge, modify, translate, or create a derivative work based on the subscribed products. And think about if we're extracting data from this, if we're transforming this into a data set that is based on some subset of this product, is that a derivative work of this? Maybe. So derivative work actually has a fairly specific meaning in copyright and in intellectual property, and it's somewhat different from the colloquial use of a derivative work. So just thinking of the word derivative, you might think, yes, I derived this from that. That doesn't necessarily mean that it's a derivative work of intellectual property. If it's transformative use under fair use, then it shouldn't or might not be a derivative work. But even if so, this clause should probably give you a little bit of pause in what you're creating and how the vendor is going to interpret that. So that is something you might want to consider there. The second point, you may not remove, obscure, or modify in any way any copyright notices, other notices, or disclaimers as they appear in the subscribed products. That sounds pretty innocuous, and that makes sense when you're thinking of using the materials in a human readable way. So if it's humans reading things, maybe you can share it with people, but they don't want you to remove that identifying information that lets other people know who the copyright holder is. That's a relatively reasonable restriction. But if you're thinking about computational uses, if you think about the data cleaning that's going to go into turning a whole bunch of PDFs that you've downloaded from this website into a bunch of standardized metadata. Probably some of the things that are going to come out of that are going to be disassociated from their original source are going to be copyright notices. You'll notice in that table that I got from Google Books, there was not a copyright notice identifying which book each word was from, right? So that's something that is, probably going to be more of a technical violation than something you're really going to get in trouble for. But it's also something that you don't want to accidentally find yourself in breach of your contract, and you don't want to make innocent things like that a breach of contract. So the next one is a big one. So you may not use any robots, spiders, crawlers, or other automated downloading programs, algorithms, or devices to continuously and automatically search, scrape, extract, deep link, index, or disrupt the workings of the subscribed products. So disrupt the workings, sure. You can't go in there and monkey with it and make it not work for other people. Super reasonable. These other aspects of it, even if computational access were allowed elsewhere in the contract, this would mean that, yeah, you can download all of it and you can use it computationally, but you have to do it one by hand. And if you have a data set of 400,000 items, that's going to take a very long time. That's going to be a lot of grad student hours. And it's unnecessary if it's otherwise allowed, right? So that is something to look at. In this case, this contract wants you is saying you can't do that because they want you to use their API instead. As Yet talked about, that's frequently that's going to be the best option for you as well. It's going to give you that's going to let you skip several steps of data preparation, basically, and let you start with structured data that they have provided. But it's possible, it's conceivable that maybe their API doesn't give you the sorts of information that you actually want from it, and then this could still be a problem. And then the fourth bullet point here, you're saying you will not substantially or systematically reproduce, retain, or redistribute the subscribed products. Is creating your data set doing that? Maybe, maybe not. Might depend on the specifics. Still sounds like it might be a problem for computational uses. So some additional terms that may come up. And this is more if you're in a contract that is specifically contemplating computational uses, then things that you would want to address and perhaps negotiate. Who can access the content? Certainly you can, but what about your research collaborators? What about when you need to publish the data? What about when you need to satisfy a funder mandate to make your data open? Are you going to be able to do that? We see a lot of very interesting data sources that people work with at MIT, that people are doing really interesting stuff. Some of that involves working with data companies that are more used to the corporate environment. So they're more used to licensing data for use in a company. And if you're licensing data to a company, then you can license it and say, okay, anyone in your company can see it, no one else can. And it becomes, and that is sometimes a reasonable thing to do in that context. That tends not to work academically, and those data providers tend to get a bit nervous once you start talking about publication. And if you're going to have that nervous conversation, it is probably better to have it at the point where you're negotiating a contract instead of at the point when you have a publication waiting on it. So those are important questions. What are the terms around sharing the content? What can you do? What can't you do? And that is, so that is really the basics of what we wanted to talk about. We only have a few minutes left. We have a couple of questions that we could go through, or I think it actually might be better to just open it up for questions a little bit more generally. So have any questions come in?
We haven't seen any yet, so But everyone, please feel free to type in your questions.
And we'll go ahead and
Oh, we have a hand up from Ty. But Harold, we don't have a way to allow people to speak, right?
So I have given Ty permission to speak.
Ah, great, thank you.
Hi, can you hear me?
Yes.
Okay, wonderful. I was, I think you might have answered this, but I think I missed it. When you're talking about the Google Ngrams, it said that, so they're not sharing text, obviously, they're only sharing kind of the stripped down word count over time. What does Google itself store? Do they store the full text and then do they generate this on the fly and share it with people, or are they forced and required to just store this kind of compressed counted data?
So I think they are storing so I think they're doing both actually. So I think the data that's driving the Ngram viewer is something like the Excel spreadsheets that they let you download. But they are also storing all of the words in order in the books because of the other features of Google Books that they do, which were also confirmed to be fair use. So in addition to the Ngram viewer, for in copyright works, you can search within a book and it will tell you what page things appear on, and it will also give you what they call a snippet view, which is about 3 lines of text before and after your search term. And in order to provide that, they have to have all of the words in order. So I believe they have the full text, the image of the page, and then also their indexed data set, but they don't provide those first two to the public. The only one they provide to the public in its entirety is the extracted data for the Ngrams.
Okay, but it's still legal for them to kind of hold the full book and then do these other kind of data science related projects on that full book and then give parts of that to the public, as long as it's not like a whole. I guess that's the other question I have, is like, where's that fuzzy line of, can they share a whole sentence? Can they share a paragraph?
Yeah, and it's so those are excellent questions. And so to your first point, yes, it is part of the fair use for them to store it, incidental to providing these other things that are a fair use. So if they wanted to share the whole text, that presumably would not be a fair use. At least like the Ngram viewer is a fair use, and then we have this kind of fuzzy line somewhere in the middle where the snippet view that Google provides, which is 3 lines around it, so it's a sentence and a half, something like that, that this court has said is a fair use. So if your application uses about the same amount that Google Books has, probably okay. Uses less than, even safer. If you're using more than that, then it's going to be a judgment call, and ultimately it's a judgment call. Ultimately, it's a judgment call by a judge if someone sues you. Probably you don't actually want to get to that point, so you're going to try and guess ahead of time what you think would be a fair use, and use that as a guideline.
Awesome, thank you. And actually, one last question. So what if you weren't sharing the full paragraphs or sentences, but instead you did some kind of, maybe you wanted to share like book summaries that were generated using some NLP algorithm, where it is based off, large chunks of text, but none of that is ever shown directly. Is that kind of lawful, or does that break the copyright?
Awesome question. I think probably that would not implicate copyright. So you're not copying the actual text. You're generating something else and then sharing that. Copyright does include things like the plot of a story and characters in a story. So, you know, at some point your summary becomes so detailed and so long that it's substituting for the original, but condensing an entire novel down into a 1-paragraph summary is almost certainly going to be either not copying the thing or a fair use.
Okay, very cool. Yeah, I'll leave more time for other people to ask questions, but thank you so much. It's a very cool presentation.
Thank you. Well, so I will just put up our slide for local resources that are available to you guys. Your subject specialist at the libraries is always happy to talk to you and help you find resources for this. Yeah, is a fabulous subject specialist for chemistry and chemical engineering, and we have awesome people like her in other subject areas as well. If you have questions about access, computational access to things that the libraries subscribe to, TextMine@MIT is the email address to get information about that. We also have library support for data services at data management at MIT. And then there's another office at MIT that is not the libraries. But if you're in a position where the libraries can't, you need to negotiate for an individual data set, then OSAT might be the office to help for that. And then we also have 2 web pages listing some of the resources that we do have and subscribe to. And I see Hara has put the remaining IAP sessions in the series in the chat.